Hello, I'm happy today to continue our organic chemistry class with elimination reaction. So, reactions of alcohol. And the first type of reaction is elimination reaction. Elimination reaction. So, if we take a molecule, for example, an alcohol, the one that we know the best is ethanol. Ethanol, I write the formula of ethanol here. I'm going to write a structural formula of ethanol. And I have like that. Okay, this is ethanol. The structural formula of ethanol, we have it there. Okay, so I'm going to, so I write ethanol here. Elimination, what that means? That means we are going to have elimination of this part. Look, we have this part that's going to be eliminated. Okay, this part, the hydroxyl group and one hydrogen proton will be removed and to form ethene and water. So we're going to write here, we have ethene plus water. So ethene is an unsaturated product. Unsaturated product, it has a double bond. And an unsaturated product has a double bond or a triple bond. So when we are coming from a reactant that is a saturated product, saturated because it has only a single bond here. It has a single bond. So by elimination, we are going to have a formation of an unsaturated product with a double bond there. And the product that we have here is ethene and plus the formation of water that we have there. Water is a secondary product because the main product is ethene here. Now, this is when you go from ethanol. Now, if we use a different alcohol, for example, we use this one. If you use this, how do you call this? How do you call this alcohol? How you call it, this alcohol? We call it propan-2-ol. Propan-2-ol. We have it there. Propan-2-ol. Now, propan-2-ol will undergo elimination of water. So here, because this part is exactly the same as the other part, either this hydrogen or the other hydrogen can be eliminated with hydroxyl group. So if we consider, for example, this part is removed, so we are going to have what? We are going to have what we have now, what we have plus water. Now, how do you call this? How do you call this? Propane. This is propane. So propane. Okay, we have propane plus water. So propane, again, as you say, it is an unsaturated product that we have formed there. So this is regarding the elimination reaction. Now, after elimination reaction, another type of reaction that we are going to see is oxidation reaction of alcohol. Okay, oxidation reaction, I'm going to write here, oxidation reaction of alcohol, oxidation reaction of alcohol. Now, if I take another alcohol, the one that we like most, so ethanol, I'm going to write the structural formula there. So either you put the hydroxyl, either you put the hydroxyl group here or there, or there, or here, or there. It is exactly the same thing. It will be exactly the same thing. Now, I put it there. Oxidation reaction. This reaction happens in our daily life, above all for the people who drink alcohol. For example, when you buy an alcohol in the shop, a beer or whiskey, you open it and you leave it open for many hours. If you come to taste after hours, you will notice that there is change in the taste. This because the ethanol that is contained in your drink has been oxidized. Okay, I repeat, the taste of your drink, your alcoholic drink, the taste will change when you open it and leave it for hours. You leave it open and then you come to taste, you notice that there will be a change in the taste. So the taste will change. This because the alcohol, ethanol that is contained in the drink has been oxidized in the presence of air, because air is also an oxidizing agent. Now here, if we are in the lab, so the oxidizing agent that we use is sodium dichromate. Sodium dichromate. Na2CO2 O7 in acidic solution. In acidic sodium dichromate in acidic solution. So when you put this, when you add acidic solution of sodium dichromate in alcohol, for example, there will be formation of what you call, if this is ethanol, we are going to have an aldehyde product. And that aldehyde product is the corresponding, it will be a corresponding product corresponding to ethanol. And the corresponding product, the ethanol corresponding compound, will be ethanol. So I'm going to write this, the formula. go to have like that. Look, what we have there is ethanol. Ethanol. Okay, this is ethanol. Okay, this is ethanol coming from ethanol, and we have ethanol. Okay, so because you see here the ethanol has been oxidized. How to recognize that it is oxidized? In organic chemistry, it is not like in mineral chemistry. In organic chemistry here, the oxidation is seen by the number of bond between carbon and oxygen. Here, in ethanol, we have only one bond between carbon and oxygen. But over there, we have two bonds. So that means this product has been oxidized to get ethanol. Okay? And ethanol is not a final product. It's not a final product here. If we put excess of sodium dichromate, so ethanol will be oxidized further. It will be further oxidized to have the formation of an corresponding carboxylic acid. Okay, so I say if we have excess of sodium dichromate in ethanol, the final product will not be ethanol, but will be a carboxylic acid, the corresponding carboxylic acid, that is here ethanoic acid. Ethanoic acid. I'm going to write the formula. The formula will be like that. Okay, can you see here? It's no, you cannot see here. So I go to right, where come right here? Here, can you see? So I go to write it here. This look, this is ethanoic acid. Okay, this is ethanoic acid. So put here ethanol, and this ethanoic acid here, ethanoic acid, ethanoic acid, ethanoic acid. So the corresponding, this is the product, the corresponding carboxylic acid of the starting product, ethanol. Okay, from the starting material, that is ethanol, after oxidation with sodium dichromate in acidic solution, now we have ethanol, and then ethanol, as I say, is not a final product. It's going to continue further oxidation to the formation of ethanoic acid. We have this ethanoic acid. So that's why I say the alcoholic drink, when you buy it and you leave it open for hours, is going to be denatured, and it will go oxidation reaction to the formation of ethanol and even ethanoic acid, a little bit in small, very small concentration of ethanoic acid there. That's why the taste will change. Okay, so this is oxidation reaction. Now, There is also another reaction that we are going to learn. Another reaction after elimination reaction, after oxidation reaction. Oxidation, we are going to learn now reaction with sodium. Reaction with sodium. So, reaction of alcohol with sodium, okay, is what we are going to see now. The reaction of alcohol with sodium, if I take an example, like if I take ethanol again, okay, I write it like that. Plus sodium, okay, plus sodium. This going to form, let me write it here, start from there. So, okay, so now plus sodium. We have it there, as you can see. This is ethanol, again, reaction with sodium. Ethanol, reaction with sodium. With sodium, so I write here ethanol. With reaction with sodium, this we're going to give the product that I'm going to write here for you. So look what we have. So what is this product called? Is sodium ethoxide. Sodium ethoxide or sodium ethonellate. Sodium sodium ethanoate, okay? Sodium ethoxide or sodium ethanoate. So it's this product plus hydrogen molecule that is formed there. Okay? So this is the reaction with sodium. The reaction with sodium, when you go from ethanol, we have ethanol reacting with sodium. Sodium, this is sodium, you know that. So this will give sodium ethoxide or sodium ethanoate that we have there. This is the formula, plus hydrogen. Okay? So, now the next reaction. The next reaction is the reaction with carboxylic acid. Reaction with carboxylic acid. With carboxylic acid. With carboxylic acid. Reaction with carboxylic acid. Now, if we take, for example, a carboxylic acid, if we take, for example, this one, okay, yes, if I take this carboxylic acid, okay, if I take this carboxylic acid, reacting with ethanol, carboxylic acid, reacting with ethanol, I'm going to write like that. Okay, this, how do you call this? Methanoic acid. And how do you call this? Ethanol. The reaction of alcohol with carboxylic acid will give a formation of ester. Okay, this will give the formation of ester. So this will give what? Will give, so I'm going to write here, C let me put like that, and this will give O. Look what we have now. Look what we have there. If I put this in red, carboxylic acid, let me put it in red. Okay, let me put this in red. So the product that we have there, I left it like that. In red, I draw in red what is coming from, oh. So I show in red what is coming from methanoic acid, and in black what is coming from the ethanol. Okay, so the reaction is what we are going to finish there. The reaction between a carboxylic acid plus alcohol will give an ester. So carboxylic acid plus alcohol will give ester. So we finish here and see you next time. I'm going to finish here and I will see you next time. Okay? Now, I forgot. An exercise for you. Okay? I want you to name this product. I want you to name this product. What do you call the product of formation of methanoic acid with ethanol? It is an ester. Ester is a general name, but I want you to get the specific name of this product. This is homework for you. Thank you.